Hello, welcome back to the channel again. Let's try to tackle another problem from a LeetCode. That's course schedule 4. In the graph series, we have already covered course schedule 1 and course schedule 2. I highly recommend you guys go check out to really understand or benefit from this approach, because this approach is kind of the continue of the same series of problems. So see what we are given. So we are given the total number of courses, and we are given the prerequisites, where the prerequisite I is called AI and BI, indicates that we have to take this course AI first if we want to take the course BI. And for example, if in this pair, we have to take the course 0 if we want to take the course 1. We cannot take course 1 before we finish the course 0. Right, and also we are given the queries array, where the queries j is equal to u, j, and vj. For j's query, we need to answer if this query, whether course uj is a prerequisite of vj, and we need to answer this going to return the array answer, where the length of this array will be equal to the length of the query array, right? Because for each query, we have to be answering either it's true or false, right? So where the answer j is the answer to the j's query, and we'll be looking at these examples in the whiteboard. Let's look at the constraints. So number of courses is from 2 to, it can be up to 100. So many courses, and AI and BI in the query, they are not equal, and the length of prerequisite I is 2, and all pairs are unique, and prerequisite graph has no cycles, and UI is not equal to VI. So let's look at these things in the whiteboard. Okay, this is the whiteboard. So what we have here, we have a graph of this 3 courses, course 0 and course 1 and course 2, and we are given this prerequisite list. So the first element is a prerequisite for the second element, right? Second course. Like if we want to take the course 2, we have to take the course 1. So if we want to take the course 0, we have to take the course 1 first. If we want to take the course 0, we have to take course 2 first, right? Basically, this is a prerequisite list, and this first element is a prerequisite, and the second element is a course. So for the course 1, is there any prerequisite? No, right? Because it does not have any incoming like edges, right? These are edges, and so for the course 2, we have to finish the course 1 first if we want to take the course 2, right? And for course 3 and course 0, we have to take the course 1 and course 2, both of them, right? So basically, and for the course 1, there is no, right? We don't have any prerequisite to take the course 1. We can start taking the classes from course 1, then we can go course 2, then after we finish both of them, then we can go and take the course 0. How are we going to do this? So we need to answer this query here, each query here. So we need to check if course 1 is a prerequisite for course 0, if the course 1 is prerequisite to course 2, right? So the very intuitive answer to this question is we need to build the list of prerequisites for each course, right? What is the prerequisite for course 1? It is basically 0, right? But it does not have any prerequisite. It's empty list, right? And what about the course 2? For course 2, it's a list. It has only one prerequisite, which is 1. For the course 0, we have 2 prerequisites, course 1 and course 2. So this list will have 2 elements, right? Course 1 and course 2. And after we build this, the list of prerequisites for each course. Then we are gonna come back here and we check. This is the course. The second element. The first element is the prerequisite, and we check if the course prerequisite list has the course 1, right, as a prerequisite. Let's say course 0 has the list, it has 1 and 2, right? Then we check if this list has 1 in it, right? Then we check if this list has 1 in it, then we return true, right? And for the second one, the same thing. For course 2, we check its prerequisite list. If the prerequisite, right now we are just assuming it's a list, but it can be set to, right, for the efficient searching. In this item, in this list, we're gonna check if the course 1 is inside. So if the course 1 is right here, then we also return true, right? Basically, for this, we return true. So our task will be, the ultimate task will be how we can efficiently build this prerequisite list, right? So we have, as I said, we have already covered course schedule 1 and course schedule 2, and I highly recommend that you go and check those courses too. So all we are given here, the prerequisite list, right, and the number of courses, which is 3. Then we, by just looking at the prerequisite list, we need to be building the graph. From the graph, we need to be building the prerequisite list, right? Let's look at, before we just look at the steps, how we can solve this, and we can just look at this graph again. So let's say this graph that's how it's connected. Let's say for course 1, prerequisite is course 0. For course 2, prerequisite is course prerequisite is course 0, and for course 2, prerequisite is let's just do this. For the course 0, what's the prerequisite? It's nothing. For the course 1, prerequisite is 0. For the course 2, prerequisite is 0 and 1. For the course 3, prerequisite is 0, 1, and 2. And for the course 4, prerequisite is 0, 1, 2, and 3, right? So we have this list of prerequisites, right? So how we can build the list of prerequisites? So we can use there are multiple approaches to solve this problem, and the most intuitive approach that I would solve, that it's with the topological sorting with the Kahn's algorithm. For the Kahn's algorithm, how it works, we will need to build the in degree. In degree means what are the incoming edges to each node, right, in the graph. What is the in degree for this? For the 0, it's 0, right? For the in degree for 1, because it has only one dependence, right, which is 0, right? And in degree is 1. What's the core in degree for 2? It's also 1. What's in degree of 3? It's 1. What's in degree of 4? It's 1. Right? And we can start processing. The Kahn's algorithm works. We can start processing. We can start processing from a node with in degree 0. Right? Then after we are done taking this course, let me change the color, or maybe this one. So after we are done taking this course, then we are done. Then we just remove this edge, right? Because we are done, and this course, that the course 1, we removed its dependency. Right? So to 0, because this is already done. Then after we are done processing this course, then we decrement the in degree of this, right? Because after we are done with this, then this incoming edge will be broken. Then similarly, we need to decrement the in degree of the next course, right? It's going to be 0. And then we start taking this course. After we take this course, then what we do, then we just break this dependency. Then we decrement the in degree of 0, because 0 has this 2, right? This 2 has dependency on 1. Then after we are done taking 1, then we can decrement the 0. So in the same process, when we iterate with Q and doing this topological ordering, we will need to be collecting. Let's say for the 0, it's empty list. This is a prerequisite list, right? And for the 1, after we are done processing it's a prerequisite, then we can check that the prerequisite for the 0 it's empty, and prerequisite for 1 it's gonna be 0, right? 0, we add after we process the node 0, after we process the node 1, we add this node the list of courses that we took already to the prerequisite list of 1, right? Then here we are at 2. After we came to 2, then we are already done with 1. Then it's prerequisite, this is 1, but this is because this is a course that we took. Before we take course 2, we take 1. I mean, we add the prerequisite list, this 1 to the prerequisite list of 2. Then at the same time, we will need to update this list with the prerequisite list of 1, right? So finally, it will be 0 and 1, right? And after we are done taking this 2, right? So we just mark it, we are done. Then we break this edge. Then we decrement the in degree of 3 to 0. Then we start taking this. After we are done with this, then we add 2, right? Because the course that we took before 3 is 2. Then we add this 2 to the prerequisite list of 3. Then 2 also has some prerequisite here, right? 0 and 1. And we update this list to 0, 1, and 2. This is a list. After we take the 2 and then 3, then this will be prerequisite of 3, but 2 itself has some prerequisites, right? We also have to take, we need to update this list by adding the prerequisite list of 2 to this. And finally, after we take this course 3, then we are done with course 3, then we remove this edge, and that means we are removing the dependency of 4 on 3. Then we decrement this in degree, and we start processing this in the queue. We add in the queue. Then what is the in degree of 4? It is not in degree is 0, but the prerequisite list is 3. But 3 itself has some prerequisites, 0, 1, 2, right? Then we come here, then we update this list 0, 1, 2, and 3, right? So that's how we do. So we basically make a dictionary here. Let's say I've already included. So course 1. So why we need this set? Because after we make this set, we are going to do searching, right? Within the prerequisite list of a specific node, right? For example, like for the 1, it is prerequisite list is 0. For the 0, it's just empty. For 2, it's 0 and 1, right? And for 3, 0, 1, and 2. For 4, it's 0, 1, and 2, and 3, right? So we have this prerequisite list, or it's a dictionary, and dictionary key is node, and the value is basically, it's going to be the set of the nodes, prerequisite nodes, right? For the for the let's say for the specific node. And the we are also given this is prerequisite list. We can build this from the prerequisite initially given prerequisite, right? And so here we computed it in degree. We from that we build this graph using the prerequisite list. Then from the computing the graph, where we computed prerequisite list. From this prerequisite list, we are given this is a query. Let's say query is 0 and 1 and 1 and let's say 3, or let's say 4 and 1, right? If this prerequisite list, I mean, a query is given, we need to check if course 0 is required if we want to take the course 1, right? It looks like we just check, we take this one and we come here and the course 0 is in the prerequisite list of course 1. Yes, we return true for this. And for the second one, we take this 3, then we check here if 1 is in here, right? We can see 1 is in here, so we also return this true. Then this is course 1. For course 1, if the course 4 is required, if we want to do the course 1. Let's say we come back to the course 1, because it's very easy and efficient searching, because this is a dictionary and the value of dictionary is a set, so it's like of one time. And we basically check this 4 within the set of values, prerequisite values of 1. So then this will be returning false, right? So we need to return true, true, and false, right? So now let's look at the code. So this is the all the code. So the first step that we do, we initialize the we are given the prerequisite list and we are given the queries, right? From the prerequisite list, we need to we need to build the graph adjacency list, and we need to build in degree, right? So for the prerequisite, the first element, let's say, so 0 and 1, right? The first element will be prerequisite, second element will be course, right? For prerequisite and course in the prerequisite list, and we add the prerequisite and all the courses that they are pointing to, right? So let's say 0 and 1 and 2, right? 2. If this way and this way, for 1, we have to take 1 is basically, it's going to point to 0 and 2. So that's what we are doing here, right? We are appending this course, and we are, for each course that it's coming, this is incoming edge, right? For each course, it means we are increasing the in degree, right? So we are increasing in degree, and then there will be one course which is here 0. For the course with in degree 0, we append to the queue, because that's the course we start processing, right? And after we add this the course with in degree 0 to the queue, then we initialize this the prerequisite list as a default dictionary of sets, right? Because we want to do efficient searching. So then while queue is not empty, we pop, let's say initially the 1, it will be 1. We pop 1, then we check the neighbors of that course, right? What are the neighbors of 1? That's 0 and 2, right? 0 and 2. Prerequisite, we check for each neighbor of the course, then we add that course to the prerequisite list, right? Prerequisite list, and let's say for this one, right? So for one prerequisite list is empty. For this one is 1. This one is, let's say, this is also 1. This will be 1 and 2, right? So then we update this prerequisite list with the prerequisite list of the course, right? Then for the course, to process the next course, we need to decrement the in degree. Then if the in degree of that course becomes 0, then we append that neighbor to the queue to process and its nodes, right? Finally, after we build this prerequisite list as here, right? Then we, for each query, will be checking to build the answer, right? So we need to process queries by checking if the course is a prerequisite of another course, right? We initialize the answer 0. Then for the prerequisite and the course and the queries, this list, right? Then we need to check, we need to append this answer as an empty list. Then we need to append if the prerequisite is in prerequisite list of the course, right? Prerequisite of the course is, let's say, 1. This is a list set 0, and let's say 4, 0, 1, 2, and 3, right? If this is the case, we need to check if the prerequisite 0 is in the prerequisite list of 1, right? So in this case, this will return true. If this is true, then we will be appending this true to the answer list, right? If it's not true, then it will be, if this is not in the list, then this will be returning false, right? That false will be appended to the answer array. Then at the very end, we will be returning the answer array, right? So for this problem, there are like 4 steps to do this, to recap, right? So the first step is we need to build the adjacency list, right? Adjacency list and in degree. And the second list, for these two guys will be, we build them from a prerequisite list. And the second step is we whatever the course with in degree 0, we add them to the queue. Then we do the topological sort to build the prerequisite list for each course, right? And the fourth step, after we finish and exit this while loop, then we check for each query. We'll be checking if the prerequisite of that query of the specific course is in the list or in the prerequisite list course dictionary, right? We are storing them as a set. This will be of one time, right? This will be very efficient search. We can also do this as a list, but this is we are setting this as a set, so it will be of one time, right? So then at the end we just return the answer. So this is the optimal solution for this problem, and I did not go into detail of the topological sort and Kahn's algorithm, and if that's why I was iterating at the beginning. Yeah, I highly recommend that you go back and check the course schedule 1 and course schedule 2 in this graph series, so that will be the continue of the same problem. Yeah, I hope you guys liked this explanation with the problem going over through and problem statement and walking through the implementation in the Python. Okay, yeah, thank you. I'll see you guys in the next video. Bye.